Hello. Thank you for joining us for ShipIt number 12, Keeping Developers Happy with a Fast CI. ShipIt is our monthly virtual gathering where we bring together engineering shop folk to talk about the things they're working on and take questions from all of you that have decided to join us today. ShipIt was created as a way for us to connect with you directly in this digital world. This marks our 1-year anniversary. And thank you for joining all of these events that bring the community together. I was thinking of putting a joke in there, but I decided not to. Maybe it's too early. My name's Anita Clark, and I'm the Senior Managing Editor for the engineering blog. Today, we're talking to members of the test infrastructure team. They're responsible for making sure that Shopify's CI systems are scalable, robust, and usable. They're here to talk about their recent project, where they reduce the P95 of Shopify's core monolith CI from 45 minutes to 18. We're taking questions at the end of this presentation, so please use the Q&A mode in the chat to ask. Let's get this started. Welcome, Christian. Let's hear about your work.
Thank you, Anita. Hello, everyone. Good afternoon, good morning, wherever you're joining from. My name is Christian Bruckmeier. I work as a senior production engineer in the test infrastructure team here at Shopify. I joined almost 1 year ago, last year in summer. And I will do with you a short presentation, like around 20 minutes. And then after, I will be joined from a few other teammates, and we will do a bit of a Q&A. So yeah, as mentioned, I work in the test infrastructure team, and often I get asked if test infrastructure means that I work in quality assurance. No. So test infrastructure means we are running and maintaining the CI of Shopify. All our engineers still write their own unit and integration tests, and our team is responsible for running all the infrastructure and tools in the background. So the mission of our team is actually ensure that our continuous integration systems are scalable, robust, and usable, with an emphasis on our Rails monolith. With CI, with continuous integration, we mean, for instance, test selection, linting, like Rubocop, and also type checking with ShopIt. And some of you might wonder now, you have a whole team just taking care of the CI. Yes, in all previous jobs I worked before, there was usually like one person doing CI stuff on the side, which were just like interested, but I never worked at a company where this was like a dedicated team just maintaining the CI. And the reason why we have a dedicated team is that just the scale of our Rails monolith. So Shopify's core monolith is probably the biggest Rails application in the world. We have 2.8 million lines of code. More than 1,000 engineers work on this Rails application. And in terms of CI, we have around 180,000 tests to run. This amount grows annually by like 30%. If you run these tests like on your computer, that would take more than 40 hours. We run 600 builds a day, and we have over 400 commits a day in our Rails monolith. So seeing all this scale, like it makes sense to have a dedicated team working on this, and not just like some persons work on the side. So the problem what we face. One big problem we have is the growth. So growth in terms of engineering size, some of you might have seen it. We are planning to grow our engineering team by like 2,000 engineers in the next year. That would double our engineering team. So that is a massive growth. But also in terms of the number of tests, we have at the moment 180,000 tests. This grows annually by 30%. So by next year, we probably have around 240, 250,000 tests, which we have to run. And also the test quality of these 180,000 tests. And I don't mean that we don't write good quality tests at Shopify. It's more there are so many moving parts, and we have so many engineers and different teams that it's really difficult to have a high quality or keep the test quality. For instance, if you work in a team only on taxes and there's a test fails in the shipping component, it's really hard for you to have the context to fix or improve these tests. So last year in September, we were looking at our CI systems, and this is a distribution of our build times. And you see here that on P95, like the slowest builds what we had took around 40 to 45 minutes. And the problem with this is that this is really frustrating as a developer. As a developer, you want to quickly get feedback, you quickly want to ship your code. That's really frustrating if you sometimes need to wait up to 45 minutes to know if you introduce a regression and if you can ship to master. Another problem is money. The more time we spend running our tests on our infrastructure, the more money we spend also on the machines. Our engineers need to do context switching, which is also costing money. So that was also one side effect. So last year in September, our team said enough is enough. Let's start a project to work on this problem and to improve the CI time again. So at the beginning, we had like 45 minutes, and our goal was to have the P95 in under 10 minutes. And it's like, it was very ambitious. We knew that, and that was what we started last year in September. At the beginning of the project, we decided to do a data-driven approach. And data-driven means the progress in an activity is compelled by data rather than by intuition or personal experience. So that was important for us. Before like jumping to code improvements or infrastructure improvements, we really wanted to have data to an actual facts what we want to improve, because intuition and personal experience often leads you wrong. So we started to build a performance monitoring system to generate reports and get some insights where our bottlenecks and where we need to work on. And before I can explain a little bit more about how a performance monitoring system looks, this is short overview about our architecture of the CI system. So we run, we use BuildKite as our hosted CI system, which the big difference to other hosted CI systems like Circle CI is that the test agents can be in a self-hosted infrastructure. So hosted is only like the GitHub integration and webhooks and the web interface. And then in our infrastructure, in our cloud infrastructure, and we actually run it in Kubernetes, we can run our own test agents. The big advantage here is, for instance, that we just can aggressively scale down and up. So, for instance, if in the morning a lot of engineers start working, if we have more than 1,000 engineers, can just scale up a lot of agents. And then in the evening, we can scale them down again. We can run on different architectures, and we just have a lot more flexibility to customize these agents. And these agents, as mentioned, run in our own infrastructure, and they are based on different components. So, for instance, some components would be a Git checkout, which would check out the source code, and also restore caches, which would download caches from Google Cloud. And there are many different components. And then as a last step, we would execute the tests. So this is a view of the BuildKite web interface. And on the top level, we would have a build, and then each build would have one or several jobs. And each job would have at least several components and commands. So in our performance monitoring tool, what we did is we instrumented each of these. For builds and jobs, we just subscribe to webhooks and then send it to Apache Kafka, and then eventually it would land in our data warehouse where we can do reports. And a similar thing we would do with components and commands. And this enabled us to generate really nice reports, and we can look at the highest level at the builds and then drill down to jobs and commands level and, for instance, set priorities. In this case, this is a scatter plot. And what we did was on one side, we have the count of each command, and on the other side, the time a command takes. And that means in the right top corner, for instance, we see the commands which get executed there often and take the longest amount of time, which then would be our highest priority to improve. And this also enabled us to group these different commands a bit together. So it also showed us that we spend, for instance, 30% of the time only in preparing the agents, and only 32% we would spend in running the actual tests. And today, because we only have 20 minutes time, I will only go into the two groups of prepare agents and running tests and give some examples there. But there were many different improvements what we did in this project. The first example I want to give is for preparing agents. And as mentioned, preparing agents would be downloading source code, and then it would also include downloading Docker images and starting Docker containers. These Docker containers we use for dependencies. So, for instance, if you run our race test, we also need a database, and we would run this database in a Docker container. And here's an example, MySQL, but we would have around 7 different of these dependency containers, for instance, Redis and Memcache. And one of our first reports already showed that starting services, starting Docker containers took on P95 1.5 minutes, and on P99 up to 2 minutes, which was really a surprise because starting Docker container should be almost instant. And was just really surprising that it took 1.5 minutes. To understand this a little bit better is these test agents run on a Kubernetes node. And on each Kubernetes node, we run several of these test agents. So our initial assumption was that these nodes were just too busy, and we were running too many agents on each node. CPU was starving, and the first experiment what we did was we reduced the number of agents we run on each node, and this really improved the start time. So it went down to 20 seconds. But one constraint what we had in our project was we don't want to increase the money what we spend on Google Cloud. And if you reduce the number of agents, we would need more agents. If you reduce the number of agents running on each machine, we need more machines, which means we would spend more time, more money on Google Cloud. So this forced us to go back and rethink about this. And if you think about medicine, there's also the symptom versus cause. So think about if you break your arm. The symptom is that it's really, really painful, but the cause is that you have a broken bone. So you could now just take some painkillers and wouldn't be that painful anymore, but the next day you have to take painkillers again, so you were just hiding the symptom. And the actual cause is a broken bone, so you should go to the doctor, get a cast, and heal the bone, and not just hide the symptom or fix the symptom. So it was very similar here. So what we did was a root cause analysis, which the idea is to get to the root cause of a problem, not just to the symptom. And there are different frameworks what we can do. A very famous framework is to ask 5 times why, and with each why you dig a little bit deeper until you find the root cause. So this is what we did, and eventually found out that CPU is not the problem, but I/O. So if we go back to our architecture with the components, we have this restore caches component, which downloads different caches from Google Cloud and writes it to the disk. And right after this component, we would start our Docker containers. So downloading these caches is often over 10 gigabytes of data. So for instance, assets or bundled gems, and we would download it, write it to the disk. And if we write it to the disk, then I/O would be blocked for the time it's fully written to the disk. And while I/O is blocked, the machine is basically frozen. So we did 2 different things to fix this issue. One was we increased the disk size of our machines to because in Google Cloud, the speed, how fast you can write to disk, depends also on the disk size. And the second thing what we did is that we marked these caches as read-only, which allowed us to share them between each of these test agents, and we only needed to download it once per machine. And this is one of our reports after we introduced this change. So you see here, our P95 was around 1.5 minutes. And then after we increased just disk size, it went down to around 25 seconds. And then we also implemented these read-only caches, which improved it even more. So now we write a lot less data, a lot faster to the disks. The second example today I want to show is about running tests. So if we go back to our build distribution at the beginning, we see 2 different clusters here. One cluster is around like the 20 minutes, which is our median. And then we have another cluster on around 40 minutes, which was our P95. And our strategy in the beginning, because we wanted to improve the P95, was we get a list of the slowest tests every morning, and then we would go through these tests and try to find a pattern. And very, very quickly, we found a pattern of timed out tests or timed out jobs. So here you see usually the jobs finish in 10 minutes, and then there's one job times out after 30 minutes and then has to retry. To understand this a little bit better, we have 2 different kind of timeouts. So we have a timeout on the job on build kite, which is around 30 minutes. But we also have a timeout on each test, which is implemented in our test agents, and it depends what kind of test it is. So for instance, unit tests would get a 10-second timeout, and integration tests would get a 30-second timeout. So the timeout on build kite worked fine, but the timeout in our tests wasn't very reliable. And how we implemented it was Ruby ships with a timeout module. So you see here timeout, and you could just execute any code in this block. And if the block takes longer than the amount of time you specify, it would raise an exception. So every test in Shopify is wrapped into this timeout block, and we would make sure with this that the test wouldn't take longer than like 10 seconds or 30 seconds. But what we found out that this timeout block is not 100% reliable. There are like different blog articles online which describe the different issues with this timeout. And we found out that especially, for instance, with background jobs, it's not very reliable. So we are thinking about different approaches, but eventually we just decided that these tests are broken and they need to get fixed. So we decided to remove them for now. And if we remove tests, we just don't delete randomly tests from our test suite. We always investigate, create reports, and then we create a pull request and notify the original authors, say there's a problem. And then we also have an internal dashboard for each team, which shows how many skipped tests are in their component or in their area that they work on. So they know that we skipped some tests and they can fix it. So with these initial reports, what we did, we found around 10 tests which were not reliable timing out. So that was our build distribution at the beginning. And then only by removing these 10 tests, we improved our P95 by around 10 minutes, which was really a surprise for me, to be honest, that only 10 tests had such a huge impact on the whole test suite. And then thinking about the 80-20 rule, which says that 80% of the outcomes are caused by 20% of the input. And this is very similar, like our 10 tests, that's not even 1% of our like 180,000 test suite. That's less than 1%, but they cost so much time in our test suite. So only by focusing on these 10 outliers or the 20 slowest percent of our tests, we had a huge improvement. Yeah, as a summary, if you work on performance critical stuff, it's important that you have a solid data reports and data-driven approach. We spent at the beginning a lot of time setting up proper reports. Before you start fixing something, really invest some time and do a root cause analysis to really understand the problem and get to the bottom of it. And remember the 80-20 rule, that focus on the 20% of your slowest tests, and they will have a huge impact on your whole test suite. And now I would like to invite my colleagues to join me for a quick Q&A.
Hello, folks. I'm Eduardo Nunes. I'm the manager of the test infrastructure team. I've been working at Shopify for 4 years already. And it's a pleasure to be here, and thank you for joining us. Kim, do you want to go next?
Yep. Hey, I'm Kim. I've joined just about a month before Christian, so I think it's 10 months now that I've been here. I'm a staff production engineer, I guess, on the team, and we might have lost Jessica. Maybe she'll be around. Oh, okay, great. Jessica's there. Go ahead.
I don't know why it turned off my camera. So my name's Jessica. You can see my face. I have been working at Shopify for 5 years. Maybe that's why the video stream decided to turn me off. I'm a senior production engineer. Yeah.
I'm dying at this. I love it when things like this happen. And I love that you're a ghost right now, Jessica, talking to us about test infrastructure from the afterlife. But this will be fun. Okay, so let's start it into the questions. Remember, everyone, you can ask a question in the chat. Oh my God, you're back. Yes. Amazing. Everyone needs to see your cute face anyway. So, so let's get into the questions. You can ask, use the chat mode, Q&A mode in the chat to ask your question, and we'll get to it as soon as possible. So let's start with the first one. How many of your tests are integration tests or end-to-end tests with a browser? If you guys have insight to that, I'm not sure if you do.
Yeah, I was quickly looking at a recent run here. So For the browser tests for core, it's reporting only 55. I think a lot of those tests are handled by another module, maybe. We've also got a category called slow tests, which are more likely our integration tests. It's kind of hard to define exactly what's completely a unit versus like an integration and how deep that integration goes. So for our slower ones, which are probably accessing the database, we've got just over 3,000. And then for the kind of in the unit tests, which also includes some integration, it's over 182,000 right now.
Awesome.
Yeah, we don't.
Oh, sorry.
We don't have like precise data. Sorry, we don't have precise data about this because for our infrastructure, we kind of treat the tests in an agnostic way. We just provide developers the tooling to run the tests, and we don't have any special feature related to any special case of tests, right? So we try to always provide service and CPU, RAM, everything that they need to run their tests, independent if it's a unit test or an integration test.
Great. Anyone else want to add anything? Awesome. Okay, the next question is, how many members are part of the test infrastructure team?
I think I can take this one. We are a relatively small team. We are only 5. Apart from us here in this chat, we also have Apostolis, our Greek folk that lives in Berlin. Unfortunately, he couldn't join us today, but I think he's in the chat, so he's together with us somehow. And yeah, we're a relatively small team. I can take this opportunity also to say that we are hiring, and we are trying to focus in folks that are between the GMT -5 to GMT +2. And if you folks are interested, please send us your resume, and it would be awesome to work with you.
So check the Shopify careers page. Is there a specific job posting that they should look at, or just use the general developer one that's out there?
Yeah, it's we don't have a specific one for our team, but you can apply to any developer or production engineering job. And if you mention that, okay, I know about the test infrastructure team, then there's a high chance that you're going to be interviewed by us.
There you go, guys and girls. Like, get in there. That is coming from the horse's mouth. Like, there's no other source of truth happening. I'm going to kind of jump on that question. Like, how is test infrastructure like kind of a niche thing? Like, are a lot of other companies have dedicated teams to test infrastructure? I imagine, the big flag ones, obviously, because they're massive. It wouldn't make other sense. But is it only at that level? Are we at like that level where our teams can get away with it, or no?
I can take this. Like what I said in the beginning, it's the first company where I worked where they had like a dedicated team. Like if you have, I don't know, 20, 30 people or something, I guess maybe there's one person dedicated, maybe a bit more working on this. Maybe if it's getting even bigger, then it might make sense to have somebody more dedicated or a team. But like most teams I worked on were like between 15 and 20 people, and there was like not a dedicated team, not a dedicated person even. Just somebody did it on the side.
Right. Any of you guys have insights to your other companies that you worked at, if this was something that was a thing? It should be, obviously. And as a former QA person, obviously I care about testing. So
yeah. I've worked in many other companies, and Shopify is the first one, but I think Shopify also is the biggest one that might be related. And yeah, and as Christian mentioned, it's not just because of our big monolith, but Shopify has, I think, more than 1,000 Git repositories. And so there's a lot of things going on. our team has some emphasis and focus in this monolith, but we also provide support to all engineers and all service. And this ends up making like the needs to have an entire team dedicated to this.
Great. Thanks for that insight for my question that I piggybacked on there. So let's go on to the next question. Is the test infrastructure team solely focused on test infrastructure? Or I think we've established that, but do members of the team have to focus on other initiatives other than test infra?
I guess I can answer it. The answer is yes. So at Shopify, even though we're the test infrastructure team, it just really depends on the project that you need to work on. And sometimes we get pulled away for a different project. For example, we're working on something not really related to test infrastructure. Right? It's for a hosting migration from one solution to another platform. So yes, I guess that's the answer.
Great.
Yeah, I can add a bit more on this. And although we may working in some other projects, they are related to CI somehow. For this specific case that Jessica mentioned, it's because we are the biggest consumers of packages at Shopify, because we build all the applications, so we download and upload packages. And that's why we were the team more close to this problem and the team that has to deal with it. But apart from that, we are like fully focused in the test infrastructure, because like Shopify is constantly growing. Even if we don't add new features, we still have to improve our platform to support the load that is constantly growing and the number of engineers too.
Great, thank you. Okay, our next question is, do you use a managed Kubernetes service like EKS or GCP? Well, I guess we're Google folk here, so that's probably what you guys are running, right? So GCP, if anyone's wondering. Let's go on to our next question.
Did you want to talk about that, Edward? Because it's kind of managed, but like we have a fancier system like
let's talk about the fancier thing then.
I'm new to Kubernetes, but yeah, like Scrooge is our cloud management though. No, our Kubernetes management essentially.
Yeah. Yeah, we run on Google, and we use the Google managed Kubernetes service. But for us, that was not enough. So we have a set of Kubernetes clusters. But in order to run the tasks, we also run Docker daemons in each node. It's not slightly, it's very complicated. So I think I won't be able to give an overview in a few minutes.
I'm going to come for you for a blog post then.
Yeah, I think it'd like to be a good candidate for an entire blog post, how we do this. But in general, it's just like we have the Kubernetes clusters, we run pods there. The agents, they run as a pod, but we also run a daemon set, which in this case is a Docker daemon. And so when a job starts, the boot of this job runs in a pod, but the real command that the user defines in their pipeline is going to be executed in a Docker container in this special daemon set, the Docker daemon. So it's complicated, and it's something that we can definitely write a blog post about this.
Yeah, you've said it now. I am going to make this happen, people, at some point. Let's move on to our next question. Do you run end-to-end tests on the UI as well as every check-in? Or is this like insights into like people, individual project teams, decisions?
I can try to answer that. So I work as a backend developer before becoming a production engineer. So we run the infrastructure, so we don't actually deal with the test itself unless it's creating trouble for everybody. As far as I know, our front-end developer do have end-to-end tests on the UI. I'm not sure what you mean by every check-in. Like, do you mean like every?
I guess, yeah, probably every commit, I would imagine.
Yeah. So I think for every PR we run tests. So I assume yes. Yeah.
Yeah, our Shopify strategy for CI is basically that on every time that you push your code to Git, we run CI. And the pipeline depends on the project. For Shopify monolith, we have a very big pipeline, of course, but some other projects just like a very short and small pipeline that runs tests and linters, and that might be all.
Awesome. Okay, let's move on to the next question. How was communication between the infrastructure? Like, how do you manage communication between the developers and the infrastructure team?
I can maybe try. There's like different ways. For instance, if we disable tests, then pull requests, then we just try to tag people. Then also we do like announcement in Slack and emails, and we also have documentation that are basically the three major things. And we have a support team. Like every one of us is on support during our work hours, so people can like ping us and say, I have a problem here. But these are like the main things how we communicate with the developers.
I can also, sorry.
Yeah.
Okay, I can also add something. So we do twice a year, we do developer happiness survey. So we ask them like surveys about, well, like you like what, like our tools, what's the biggest pain point for you? But yeah, like what Christian said, in general, if we have any questions, it's pretty easy just to, I don't know, find the person on Slack and just message them, and then they talk to us, or they just complain directly on our channel.
That's hilarious. Okay, let's move on to our next question is, do you run on spot/preemptible instances? If so, have you had issues with this model?
Yeah, I think I can take this one. In the past, we were using preemptible nodes, and although they are very effective from the cost point of view, they were a nightmare for us as well, especially for the pipelines that demand a lot of machines. For small and short pipelines, that was not a big deal because they won't be directly affected by this. But if you think like a Shopify core monolith build requires lots of machines, and there was like a very high likelihood of one of those machines being preempted at the time that the build's running, and then we have to restart. So the builds were taking more time. We had to rerun multiple tests because we basically lose the information when the node is preempted. So at some point we just decided, okay, let's try not to use preemptible nodes. And it turns out that our builds were way faster and would pay off the cost of having more stable machines. Although what we do, we have a system called Scrooge. Kim just mentioned it. And basically the system analyzes the demands we have for builds. Like we query build kite and check how many jobs are waiting and how many jobs are running. And based on that, we decide how many agents we need in our infrastructure. And we manually, but it's like the tool that does this, we basically scale those clusters up and down. So we also save costs by doing this. So during the day, we do this like every minute. So at peak, we may have thousands of machines, but at some point during the day that there is no developer working, we may have 0 machines running.
Great, thank you. This is a good question. Why build kite, and how is the overall experience?
I think I can take it because I was also a little bit talking about it in the talk. So one I wasn't here when this decision was made because that was like 5 years ago or something. But one reason is just like that we can run in our own infrastructure, which is not possible in like CircleCI or Travis or something. So that was one of the big advantages of BuildKite, that we run our own infrastructure. We also run, for instance, different machines for iOS. Like we have Mac machines as well, so we can support different architectures, not just Docker. And it's just like more flexible because we can implement our own test agents. But that was, I think 4 or 5 years ago already, when we migrated to BuildKite.
Yeah, BuildKite basically gives us this flexibility because at scale of Shopify, it's quite hard for a provider to provide the service that we need, right? For example, in this project, we had to go down to the hardware level and decide, okay, let's increase the disk size because then I'm going to increase the speed of disks and then we're going to have faster builds. And this was not just the only case. There are many solutions that we have to go down to the hardware level. And if we will be using an external service, probably it wouldn't be possible. And apart from that, Shopify runs a lot of services, and it's a way easier for us to integrate those services if we run CI in our own infrastructure.
Awesome. Okay, we're coming up on 15 minutes left in our event. If you have questions, please enter them in the chat. Use the Q&A mode, and we'll get to them. So let's continue on. Our next question is, how do you implement security in your testing, especially if your tests needs to be run with external services?
I can take this one as well. We by default, we don't talk to external service when we're running tests. You think about it, for example, talking again about our monolith, we run 108,000 tests. If people decide to access external service, it would be a nightmare. And also, whenever you access an external service, your tests lose a bit of determinism of it. So it ends up generating more noise than signal. So it's like one of the best practices we adopt is basically don't access external service. If you need to test something that that will be better tested when you access an external service, probably can create a mock of it. Or if possible, we run this external service as a local service as well, and then you can test it locally. And by doing that, we basically don't have to worry that much about security. As I mentioned, we also run the user code runs in a sandboxed Docker daemon. So it's kind of isolated, doesn't have access to credentials or anything like this. And yeah, basically that's the answer, I guess.
Thanks. Okay, our next question is, do we use Docker in Docker? If so, how do you improve the performance there? And if not, why not?
Yeah, we use Docker in Docker, and we basically use Docker in the Kubernetes Docker. And one of the reasons was to have this sandboxed environment. Another reason is because if we do that, we prevent like a test or like a build to affect the Kubernetes cluster and node because it's isolated. And also, for us, it was better from performance point of view as well, because the Google managed Kubernetes clusters, they run a specific version of Docker. And in our case, we need to run a different version. And by running our own Docker, we can decide whatever version we're going to use, whatever storage layer we're going to use as well. and this allows us to have a better performance.
Great. Okay, our next question. Would we ever consider building our application into a Docker image and then running tests on that Docker OCI image natively in Kubernetes with the dependency contained as sidecars?
Maybe I can take this. Nobody. I mean, somehow we already do some stuff of it. Like as said, our builds run in a Docker sandbox. Like the Docker image wouldn't contain the source code. So what we do is like we have a test Docker image, and then we mount in the source code because we don't want to build every time like the image before we run tests. We don't run it natively in Kubernetes because Otto already explained that we don't want to interact in our CI system directly with the Kubernetes. So we have our own Docker in which we run our CI image, and also like our dependency containers. They also run in Docker, not on the Kubernetes Docker. But it's the main reason is like isolation. But everything runs in Docker. We just mount stuff into it.
Anyone else want to add anything? Okay, cool. Our next question is, since our code base is very big, have you encountered flaky tests and how do you deal with them?
I guess I can go.
Oh, yes. Jessica has a blog post that I've posted, but I will repost it so everyone can look at it because it's really great. But go ahead. Sorry, Jessica.
So in general, yes, we have encountered many flaky tests. And then unfortunately, those tests are a lot of times, because the code base are so big, some of them are abandoned. So the teams cannot, there's no team that own that part of code anymore. So we can't really ping the team to fix it. And then often, I guess, they're hard to debug a lot of times. So they might not have enough time to debug. But the impact was, it causes every single person who's creating PR to fail on this test unrelated to their code and not knowing why is it failing, or it's not their domain of knowledge, which slows down our developers a lot. And as you know, developers are often the most expensive asset in a software company. So what we did is we were trying to manually squash them to beginning, and then as you can see that we have many tests, and then they all the tests often it's context, it depends on the context. So a lot of times, even if you try to fix it takes a long time to understanding what's going on and whether what you can do about it. And it's just almost like our tiny team of 5 people cannot outpace all thousands of developers trying to constantly merging more tests and knowing that it's going to be flaky sometimes. So we decided that we have to have a system that automatically does it. Part of the solution was building something called we call it the selective test. So you don't, instead of running every single test cases when you push a change, you run the changes that's related to, you run the test that's related to the change that you made in the pull request. And yeah, I think that's the answer.
If anyone else wants to add something, sure, go ahead, Eduardo.
Yeah, because that's something in the beginning when people were talking about this, and we came with this idea of running last tests. There was a question whether this would really help on the flakiness or not, and we bet on it, and we have reports that prove that it definitely affects, because instead of running all the tests, we just reduce the surface, right? So if you change one model, you're not going to run all the tests. You're going to run just the tests that are related to that model. So the likelihood of you facing flake tests is going to be reduced. And this is proven to work. And we, at some point, I think our quality of CI was 50%. and we are able to move to 98%. So now like just 2% of the builds may fail because of flake tests. And that's was an awesome outcome of this project.
For me, it was really interesting when I joined, because I worked in like more smaller teams, and there's always like the discussion if you like symptom versus problem, and if you're hiding a problem, if you just like not run it or you retry or something. And it's in small teams, that's probably true, that you want to like, if you're only 10 or 20 people, then I can just go over and say like, I think your test is broken, or like, I know you worked on this like last week. But that doesn't work anymore if you have 1,000 engineers or 1,500 engineers, because if something on text breaks and I work on shipping, I have no context, and I don't know who worked on this recently. So yeah, it's not that easy on this scale.
Yeah, I was going to say to you, I don't know if it was mentioned, but we do retry tests up to 5 times, because just with the infrastructure, how things are set up, something can go wrong with the node. So if it fails once, okay, whatever, we'll try it a few more times. And if it passes once, we're okay with it. But we've got tons of stats going on. So we do have a report ongoing, and each week it's kind of looking at which are the worst offenders, because there's some that could be random, and then there's some that stand out that tend to fail the most often. So those will either be kind of skipped and show up in that report that Christian showed in the slide. But we'll give them a few tries, and then we'll still call out ones that cause the most problems.
Great. Okay, let's go to the next question. Do your developers make PRs directly off the default branch, or do they produce feature branches which multiple teams merge PRs into? If it's the former, do you still run all tests on master?
I guess I can go. It very much depends on the team. I know some teams, they prefer to have feature branch and then merge to master, because they just don't know. There's a lot of uncertainties. They're building prototypes, but most of the time it's merged directly onto master. We run tests on both the feature branch, and then once the code gets right, I think we merge the code to master, and then we run all the tests again on master directly, and then afterwards we ship the code if everything passes. Yeah.
Awesome. Okay, our next question is kind of coming back to the report that Kim, you touched on, and Christian, you touched on in the presentation. Would like to know more about the report and what tools do you use to create that report?
Can take, or Kim, do you want?
You go ahead.
So this system, what we use is like our internal data warehouse system. It's based on Apache Kafka, which then we publish to this pipeline, or to Apache Kafka, and then eventually will end up in our data warehouse, which is, I think it's Presto SQL, and then we can query data with like mode, that are basically the tools. But this is like Shopify internal, like this is for all of Shopify. This is not like what our team picked to go with. This is just because, just to unify it a bit, and not every team picks their own tools. We have the setup, and the nice thing is there's also like a dedicated team maintaining this, and it works really nice. If you set up a new project, you don't need to take care to set up your own Kafka and your own data warehouse in mode. So it just it integrates very nicely if you have a new project, and it was very easy for us to set up all these reports, because all of the tools in the background, they were working, and we just needed to like plug them together and do the reports what we need, and we didn't need to like spend lots of time getting the tools ready and investigate which tool to use.
I can add a bit on this. At Shopify, as we have our team dedicated on CI that takes care of building the CI platform and maintaining it, at Shopify we had a huge team on data. I think it's more than 100 people. And to be honest, for us, it's like a black box. We get an endpoint and we push our events there, and they magically are available to us in a query tool called Mode. But we don't need to know about this, right? So we basically can ignore this as engineers. We just, okay, there is a huge team that takes care of thousands of or millions of messages per second. And we know that we are one of the teams that generate a lot of data, because we generate data about the builds, the jobs, as Christian mentioned, the commands and components, but we also generate data about each test execution. So we know exactly when a test failed, when a test passed, the error message, the line of code, and everything else. And we basically don't care. We just push all this data and magically it's available for us. It's awesome.
Yeah, and that data is super helpful when it's flaky, because we can say, oh, here's in this report, this is exactly when it failed, the error message, the build that it was on. So it's kind of our proof. It's like, okay, now you go fix it. Here's the evidence. No.
So this is our last question. We have 2 minutes left, so let's go. When you retry tests, do you run the entire selected set of tests, or do you try to filter further just to the failed tests on retries?
I can try and grab this one. So when we're retrying, it's just retrying the failed test. We also keep track of the test order that's run. So if you do see a test that flakes, we have something called bisect, and it'll try and you can do a reduction to see if it's not your test that's actually flaky, but the state that wasn't properly cleaned up from another test that was affecting it. So the retry will just retry that test. But if you see something flaky and you don't think it's your test, you can go and grab where it's failed, run it into a bisect tool, and it'll see which one of the tests that ran before your test is messing up your state. I don't know if anyone wants to add more to that.
Great. I want to thank all of you for sitting in the hot seat and taking everyone's questions. And I want to thank everyone who's joined us today. We'll have a video of this set up afterwards, and it'll be available. I'll send all the registrants with a link to the video in the email. We're hiring 2021 engineers in 2021. So head to Shopify Careers and see the open roles. For those of you that are taking Eduardo's message to heart, head over there, submit your resume, make mention that you want to be on this awesome test infrastructure team. Thank you for spending this hour with us. We're touched by everyone who's joined us. Thank you for making, attending, so that we're here at our year anniversary, and we'll be continuing in 2021 with ShipIt. I hope you've gotten a lot of information out of our wonderful guests about CI systems and operating them at our scale, and maybe it will help make some decisions for you at your workplaces. One more thing, we have a survey that'll come out with the email. Please, submit your answers. Tell us what you want to see. Tell us what you don't like. We want to improve and make this a better experience for you and everyone else that comes afterwards. Our next event is on April 28th. We're talking about performance testing, load testing. We'll see you there. Keep an eye out on all our socials and the engineering blog, and we'll let you know when that event registration opens up. Thank you all. Thank you guys. And I hope you have a great rest of your day, evening, nighttime, going to bed now. Thank you all for joining us from all across the world. It's been amazing. Thank you.